This group of questions, 15 through 17, the prompt is, what is the discriminant of these standard form quadratics? Well, the first thing we have to remember is what the discriminant is. And discriminant is b squared minus 4 times a times c. And when we find this class, first thing we want to do is find a, b, and c. And remember, when we are finding the discriminant, the first thing we have to do is make sure everything is on one side of the equal sign, and we have that. Our a, b, and c terms are all on one side. Our y value we can actually ignore, because if we were solving for this, we'd be using y equals 0. So there's our equation. Let's identify a, which is -1. B is -6, and C is equal to 7. So we've got B, so B squared, remember, whenever you plug a variable in, you plug it in with parentheses. -6 squared minus 4 times -1 times 7. Let's go ahead and put that in our calculator. If I can move that somewhere, we can actually see the equation. Looks like, oh, there we go. I can get it over here. Okay, so we've got parenthesis -6, since b was 6. Sorry, b was -6. So -6 parentheses squared minus 4, and then in parentheses -1, and then parentheses again 7. See, every variable that we've plugged in, we've used parentheses. First equal, we've got 64. So our discriminant for this equation is 64. Let's take a look at the next one. Well, all the terms are on one side. It's in standard form. We can ignore the y, and we can write our a, b, and c. A is 3, b is 4, c is -10. Make sure you see that negative. So now let's go ahead and write our equation for our discriminant, b squared minus 4ac. b is 4, so it's going to be 4 squared minus 4 times a, which is 3, times c, which is -10. Now I've already, oops, I forgot to put 64 here. I've already done these in advanced class. I would suggest, though, that you do put this in your calculator to verify you're getting the same answer. You should end up with 136. And then the last one, number 17, same situation. All the terms are on one side. We could ignore the y value because that's going to end up turning to 0 if we were to solve it. Let's find our discriminant by finding a, b, and c. A is equal to -3. B is equal to -6. C is equal to 4. Again, class, just reminding you, this is part of the quadratic formula. That means we don't have to worry about pulling out any GCFs, changing it a to 1. You just find a, b, and c and solve. So let's do our discriminant. B squared minus 4ac. B is -6, just like it was in the first equation. -6 squared minus 4 times -3 times +4. Let's put that in our calculator just to practice. So I've got parenthesis -6, parenthesis squared minus 4, parenthesis -3, parenthesis 4 equals, and I've got 84. So there's your practice of finding discriminants. Okay, number 18. Excuse me. Find the solutions by factoring. Remember, class, I told you sometimes I'll require you to solve it a certain way. If I didn't ask you to solve it a certain way, you could pick complete the square, quadratic formula, or factoring. In this case, I want you to factor it. So remember our steps for solving or finding solutions. First thing is make sure the equation is going to equal to 0. And I'm going to go ahead and move everything to the left because I've told you that just makes more mental sense to me. But you can leave it on the right hand side if you want to. But we know the y value is going to be 0 because we're looking for solutions, which are x-intercepts. And for x-intercepts, y has to be equal to 0. Alright, our steps of factoring is find the GCF. Alright, our lowest coefficient is a 1. That means we have to have 1. And since a is positive, we don't have to pull out any GCF. I just put a line through that. Positive 1 won't change anything in our equation. So we can get right to factoring. Let's find our a value is 1, b is negative 4, c is negative 12. Let's create our combination table. A times c is negative 12. B is negative 4. Let's take a look at our combinations. 1 and 12, no good. 2 and 6, looking pretty good. 6 minus 2 is 4. That's no good. 2 minus 6 is negative 4, and 2 times negative 6 is negative 12. There's our combination. And we've got a equal to 1, and that means we get to use the shortcut. So now we can just go ahead and go right to our equation. We've got no GCF, so I don't have to worry about copying that down. This is going to be x plus 2 and x minus 6. That came right from our combination table, equals 0. And now we're finding solutions. We're not just factoring, we're actually finding solutions. That means let's figure out what x values. We'll change this. We'll change this equation to 0. Either x plus 2 has to be equal to 0, or x minus 6 has to be equal to 0. This is going to be negative 2. It's going to be positive 6. So our solutions are negative 2 and positive 6. All right, let's do one more. Number 19. Factor. Okay, factoring, we've got to get all the terms to one side of the equal sign. So let's move the 12 over where it belongs. 6x squared minus 21x. When we move the 12 over, we're going to end up with negative 12 equals 0. Remember, your equation has to be equal to 0 in order to solve by factoring. All right, let's take a look at our GCFs. Start with 6. 6 doesn't go into 21, no good. 5 doesn't go into 6. 4 doesn't go into 6. 3 goes into 6. 3 goes into 6 2 times. 3 goes into 21 7 times. 3 goes into 12 4 times. We've got a GCF, and our a value is positive, so our GCF is going to be positive 3. Let's pull it out. What's our leftovers? And notice we couldn't plot an x because we have a c term. That means all the terms do not have a common variable. 3 times 2x squared gets us back to 6x squared. 3 times negative 7x gets us back to negative 21x. And 3 times negative 4 gets us back to negative 12. All right, our GCF has been pulled out. Let's identify a, b, and c. A is 2. B is negative 7. C is negative 4. Let's find our combination. A times c is 2 times negative 4, which is negative 8. B is negative 7. It's going to be fast. 1 and 8 look good. 8 minus 1 is positive 7, no good. 1 minus 8 is negative 7, and 1 times negative 8 is negative 8. So we found our combination. Now, we can't use the shortcut because a does not equal 1. We're going to have to go through our factoring steps. So remember what they are, class. Don't forget your GCF. The a term doesn't change. The c term doesn't change. The only thing that changes is the b term gets split between our combination. So the b term becomes plus 1x minus 8x. Next step, let's group. The first two terms get grouped. The second two terms, or the last two terms, get grouped. And all we have to do is find what are the GCFs. Whoops, let's not change that color. What are the GCFs of each of these groups? Well, the coefficients here are 1 and 2. So 1 is our GCF here. We can ignore that. We do have a common variable, though, of x. And then on GCF for the last two terms, 4 is the smallest coefficient. That goes into 8, so our GCF is 4. But don't look at this sign, class. Look at the first sign. We start off this group with a negative coefficient. That means our GCF needs to be a negative 4. So next step, let's factor those groups. So we're going to have 3. Pull out the GCF of x, and we end up with 2x plus 1. X times 2x is 2x squared. X times 1 is 1x. We're good with that. Pull out the negative 4 as our GCF. Negative 4 times positive 2x is negative 8x. And negative 4 times positive 1 gets us back to negative 4. And now let's check. We've got a common binomial. Green light. We are good to go. If the binomials aren't the same, stop and figure out your math error. Last step, we're going to convert our equation one more time because we have a common binomial. That means we can factor that out, and we're going to end up with 3 times x minus 4. There's our two values that we factored out in the previous step. Here is our common binomial, which can be written once because it exists in both terms. Okay, we've just converted to intercept form. So now we can find our solutions by finding what changes x minus 4 to 0 or what changes 2x plus 1 to 0. Now remember, this 3 is irrelevant now. As far as finding solutions, we ignore it. All we need to do is find what x values will change each of these binomials to 0. This is going to be positive 4. This one we have to do a little bit more work. 2x equals, we're going to subtract 1 from both sides. That's negative 1. Divide both sides by 2. 2 over 2 is 1, and x is equal to negative 1/2. I'll circle this one too. So our solutions are either negative 1/2 or positive 4. All right, we'll start up with question number 20 on the next video.